So hello guys, today I'm going to discuss the PYQ of Physics IAT 2024. So चलिए शुरू करते हैं. So the first question is, on a circular track, two cyclists Abhijit and Vani starts moving in opposite directions from a same point. Abhijit moves with a constant velocity and Vani moves with a constant acceleration and starts from rest. They meet on the same track with the same speed. Which of the following is correct? So it's quite a easy question. So let's start. Let us assume the velocity of Abhijit as VA and acceleration of Vani as A. So the final velocity of Vani would be V equals to U plus AT. U is 0 as mentioned. So V equals to AT. So acceleration will be V upon T. And in question it is mentioned that final velocity of them are same. So VA equals to V also. So the distance traveled by Vani is equals to ut plus ut is 0 half a t square equals to ut by 2, and the distance traveled by Abhijit, he is moving with a constant velocity, so distance covered by Abhijit will be u into t. So clearly it is visible that distance traveled by Abhijit is double the distance of Vani, so option A is correct. So the next question is consider a simple pendulum undergoing simple harmonic motion with a time period t and a fixed amplitude theta naught of angular oscillation. Its angular momentum over a fixed point of suspension exhibits an oscillatory behavior with an amplitude a. Which of the following relations between A and T is correct? So it's quite an easy question on simple harmonic motion. So we know that angular momentum is I omega, right? And omega equals to d theta by dt. Let us assume theta as theta naught cos omega t, right? As it is a circular motion, so d theta by dt equals to theta naught omega sine omega t minus times. And we know that for a simple pendulum, angular momentum equals to I omega. I is ml square, as it is a simple pendulum bob, ml square into omega. Now time period of pendulum equals to 2 pi under root L upon G, right? So square it. T square equals to 4, T square upon 4 equals to L upon G. So L is proportional to T square, right? L is proportional to T square. So angular momentum equals to M into T to the power 4 as L square. So T to the power 4 into omega. Omega is 2 pi upon omega. 2 pi upon t, so 1 t got cancelled, so angular momentum is proportional to t to the power 3 t cube. So which so again A option is correct. So it was quite an easy question. So let us move to the third problem. Third problem is like a pulley and two masses are attached to it. It is asking about the angular acceleration of the disk. So it's quite an easy problem. Let us assume, so first of all make the figure. This is m, this is m upon 2. Let us assume here tension as T1, here T2. So write the equation, force equation, right? So mg minus T2 equals to m into A. Let us assume the acceleration to be A. Acceleration of this block. Acceleration will be same for both the blocks. And equation for this is T1 minus m upon 2g equals to m upon 2 into A. So solve this equation. So let us add this to T1 minus T2 plus mg upon 2 equals to ma plus ma by 2 equals to 3 ma by 2. So T1 minus T2 equals to 3 upon 2 ma minus mg upon 2. Okay, and also A equals to R alpha for the disk, and write the equation alpha of torque. So T2 into R minus T1 into R equals to I alpha mr square upon 2 into alpha. R got cancelled, so T2 minus T1 equals to m into R alpha by 2. R alpha can be written as A. So m A upon 2. So equate it. M A upon 2 equals to minus times, right? So mg upon 2 minus 3 upon 2 ma. So 3 upon 2, 4 upon 2, so 2 ma equals to mg upon 2. Got cancelled, so a equals to g upon 4. So it was very easy question. We have to write two force equation and one torque equation. So a equals to g by 4 is the answer. So option A is correct. Let's move to the question number 4 and see what it is asking. A solid bob of a material having density twice that of a water is suspended with a massless and inextensible string of length L. So the density of bob is twice that of the density of water. So density of bob equals to 2 times density of water. Now what more? The whole setup is placed inside the water filled tank. Okay. The bob is imparted a horizontal velocity v0 at the lowest point A, while the other end of a string is fixed, such that the bob completes a semicircular trajectory in the vertical plane, and the string becomes slack only when the bob reaches at the topmost point C. So it was that case when the bob reaches minimum velocity required for a bob to reach the topmost points. It's very well known question. So minimum velocity to reach the topmost point is under root 5 GL, right? Everybody's known that under root 5 GL. We can find this by uh, writing one equation on energy conservation, and one is force mg equals to mv square by r. So simply we'll get velocity equals to 5 GL, and g should be g effective. Now the question is totally dependent upon g effective, right? So let us find g effective. So g effective weight, we will have to find the weight. Mass of the bob, mass of the bob was to rho b vg. Rho v means mg. I am writing the force. So rho v, and density of the fluid is rho w. So we have to find g effective. And we know that g effective equals to w effective upon mass, and from this w effective equals to suppose this is the body, right? So in upward rho w vg, in downward rho b vg, and it is 2 times rho w vg as a density of fluid. So weight, effective weight equals to rho w vg. This is the effective weight. Now for g effective, rho w vg upon mass. Mass can be written as rho w vg upon rho b v, and this is 2 rho w. So rho w cancelled with, so equals to g by 2. So g effective equals to g by 2. So minimum velocity required equals to 5 into g effective into L equals to under root 5 into g upon 2 into L. So which option? So the A option, again A option is correct. It was a good question because we have to relate the density also. So it was nice question. So let's move to the question number 5th and see what is asking. Consider a solid sphere of radius r floating in a pond with a half of the sphere submerged. The sphere is pushed vertically downward at the topmost point and released such that it executes a simple harmonic motion. Acceleration due to gravity is g. What is the time period of oscillation? So it is quite a well-known question. Often these questions are asked in JEE Mains also. So let's solve it. So this is this, and the sphere is halfly submerged. Halfly submerged. So mg of this sphere equals to weight equals to point force applied by it. So rho w into v by 2, as a half of volume is submerged, into g equals to rho b v into g. So V got cancelled, Gg got cancelled. The rho of water equals to 2 times density of body. Now it is saying that it is pushed quite gently pushed. So let us assume the x from this surface it got submerged x. So the extra volume, what is the extra volume that got submerged? Extra volume equals to uh, the cross section area, that is pi r square into x. That is the extra volume that is submerged. You can imagine the cross sectional area of that sphere is pi r square into x is the extra volume that is submerged. So the what is the extra force, means net external force for time period and for SHM, and external net external force is only required. So force external equals to pi r square x rho Vg. So what we have to find, what is the time period of oscillation? So time period equals to, this is it can force again equals to rho pi r square g into x. So this is can be considered as k. In SHM something multiplied with x can be considered as k. So time period equals to 2 pi under root m over k. So time period equals to 2 pi under root m over k equals to 2 pi under root m is rho b vg upon k. K is rho pi r square into g, and this is rho w, right? Rho w. This is rho w. At force is up by the water only, water fluid. So 2 pi under root rho w equals to 2 times rho b, right? So 1 upon 2 into g got cancelled. V is 4 by 3 pi r cube upon pi r square. So pi r square got cancelled r. And so time period equals to 2 pi. On simplification, it comes to be 2 upon 3 r. 2 pi under it 2 upon 3 r. And one g also, right? Oh sorry, mass is rho b, not g. So g is also here, r upon g. So 2 by 3 2 r by 3 g, 2 pi under 2 r by 3 g. So a option is correct. It was also a good question. It's a quite good question. Asking. So 1 mole of an ideal gas of volume V and temperature T is allowed to expand adiabatically to form volume to V while doing no external well, okay. Then what is the pressure of the gas? So it's a quite easy question. So we know that delta Q equals to delta U plus delta W, that is W, and it is in question it is saying that no work is done, so it is 0, and adiabatically, so Q is also 0, so delta U must have to be 0. And so delta U is 0, so temperature is constant as a NCB delta T, delta U equals to, so T1 equals to T2, means temperature is constant, so P1 V1 equals to P2 V2. So volume is volume from V2 to V equals to P2 into 2V. So P2 equals to P upon 2, and P is nRT upon V, N is 1, so RT upon 2V is the pressure. So option A is correct. Let's come to the question number 7. It was a very, sixth question was very easy, so everybody should have done this. Now question number 7. Consider the motion of a particle along the x-axis. The position of particle varies with the time t, as x of t equals to this, where omega is constant. What is the time period of motion? So it is quite an obvious question. It's very easy. So we have to find the time period of motion. So we know that for time period, x of 0 equals to x of 0 plus t equals to x of 0 also, right? So equals to 0. So it has to come 0 by any of the means x of t is what it is given, sin square omega t into cos cube omega t. So any one of them will have to be 0. Sine square omega t, right, into cos cube omega t. So for a time period, any one will have to be 0. Like 1 upon omega will be common to them. So 2 pi upon 3, this is 360 degree. This is 120 degree, and this is something more. So this is also not making any one of them 0. 2 pi upon 15. So it's quite obvious. First option is matching only. So sine of 2 pi will be 0. So A option is correct. So it will be the time period of the motion. It's very easy question, understandable, common understanding question. So let's move to the question number 8. It seems to be good questions. Let's see what's asking. Two identical boxes contains the same ideal gas. Let N1 lambda 1 T1 and N2 lambda 2 to T2 be the number of density, mean free path, and temperature of the gas in the first and the second box. One of the boxes emptied into the other one. What is the mean free? Okay, so there are two boxes, N1 T1 and lambda 1 N2 T2 and lambda 2. And for mean free path, everybody should know the formula. Lambda equals to 1 upon root 2 pi rho d square n. So it is inversely proportional to the moles of number of moles. So finally they are in the same container. So total moles equals to n1 plus n2. N effective equals to n1 plus n2, right? So 1 upon lambda effective equals to 1 upon lambda 1 plus 1 upon lambda 2. So lambda effective equals to lambda 1 lambda 2 upon lambda 1 plus lambda 2. So option number. So now for temperature, final temperature. For final temperature delta U, we will have to conserve, and we know everybody knows the formula for TF equals to N1 T1 plus N2 T2 upon N1 plus N2 by that internal energy conservation. So option number A is correct. So option number 8 was formula based. This formula is very easy. Everybody knows that. And this one is the conservation of moles. And everybody should know that formula. Lambda is inversely proportional to moles. So it was easy. So now let's solve the question number 9th. And we have to find the acceleration of the charge minus q as the time of release. So it's a negative charge. So both the charges will attract. And clearly it is visible that it's an equilateral triangle, right? L and this one is also L. So now this is let us assume this is F1 and this is F2. So it will attract, right? So F1 equals to minus times, right? Minus times KQ square upon LQ, L upon 2 I cap plus root 3 upon 2 LJ cap. So this is root 3 L upon 2 J cap. So this is the F1 by this plus Q charge, right? And F2 by F2, it will also be the force of attraction only. So equals to KQ square upon LQ into I upon L upon 2 I cap minus root 3 upon 2 L J cap. So F net equals to KQ square upon LQ, KQ square upon LQ into, so this minus this, L upon 2 I cap, L upon 2 I cap plus plus minus 3 root 3 upon 2 J cap, right? So it was a very easy question. We have to find the force against them, and then acceleration is upon mass. So 1 upon 4 pi epsilon naught acceleration equals to q square upon mass. As force is this, so acceleration will be upon mass, L cube into L upon 2 I cap minus 3 root 3 upon 2 J cap. So the option number L upon 2 minus 3 root 3. L upon 2 minus 3 root 3. So A option is correct. 2 comes out, so 1 upon 8. So now let's move to question number 10 and see what it is asking. So now let's solve the question number 11. So see what it is asking. A conducting wire carrying a steady current I is shaped that's shown in the figure below. All connected straight segments meet at right angles. What is the magnetic moment of current loop? So it is quite an easy question. The magnetic moment of this loop is asking. So we know the formula of magnetic moment is as NIA, right? So magnetic moment equals to NIA in the direction we find by right hand thumb rule. So the direction, the part of the vertical, the magnetic moment due to that vertical will be in the plus k cap, right? So n is equals to 1 as a number of coil is 1. So I into A, and the area is A into B. IAB plus k cap, and due to horizontal will be upward, right? Plus j cap. So it will be. So now let's solve the question number 12 and see what it is asking. The capacitor C1 and C2 have capacitances 2 microfarad and 8 microfarad. 2 microfarad and 8 microfarad. And first of all, it was connected to C1 and then C2. We have to find the ratio of the charges on them. So we know that the Q equals to CV for capacitors, Q equals to CV. So the for C1, Q1 equals to C into V. Potential difference across both of them is same. So it's 2 only, 2V. And for Q1 is 2V and Q2 equals to 8 into V, that is 8V. So it is asking Q2 upon Q1 plus Q2, Q2 upon Q1 plus Q2. So 8V upon 8 plus 2, 10V equals to 4 upon 5 is the answer. So it was easy question, A is correct answer. Now let's come to the question number 13. The question number 13. So atomic mass of two oxygen isotopes are this and this respectively, which with mu is the atomic mass unit. Mass of proton and neutron are given by this and this respectively. The speed of light is c. What is the difference between the binding energy? So it's a easy question. We know that binding energy equals to delta m into c square. So for O16 isotope, O16, delta m equals to 8 into 1.00727 plus 8 into 1.00866 minus that one 15.99491 delta m mu c square. And for O818, it equals to 8 into 1.00727 plus 10 of 10 neutrons, 10 into 1.00860 minus that one 17.99916 mu c square. And when you solve this, you will get delta binding. This is the B1, this is B2. Delta binding energy equals to B1 minus B2, and you will get the answer to be 0.01307, and so option A will be correct. So thank you. So the refractive indices of two transparent slabs are 2 and 2 upon root 3. They are attached together and placed in the third transparent medium of refractive index root 2 as shown in the figure. The thickness of the upper slab is 1 centimeter. The monochromatic light is incident on the upper slab at 45 degree. What could be the thickness in centimeter of the lower slab such that the deviation is 0, right? Lateral displacement is 0. So we know the formula of lateral displacement as d equals to t into tan theta. So now first of all apply that law here. Root 2 into Snell's law, root 2 into sine 45 equals to 2 into sine theta to find the angle of refraction here. So sine theta 1. So theta 1 equals to 45 degree at sine theta 1 equals to 1 upon root 2 as it goes to denominator. Now this will be the incident ray for second slab. So again Snell's law, 2 into sine theta 2, that is 1 upon root 2 equals to mu 2, 2 upon root 3 into sine theta 2. So it will be under root 3 by 2, right? Theta 2 equals to root 3 upon 2, which is equals to 60 degree. So sine 45 is 1 upon root 2. So root 2 get cancelled, 1 upon 2 this is, and root 3 upon 2. So sine theta 2 equals to 60 degree. So for lateral displacement T1, it has been mentioned that there is no lateral displacement. So there will be a lateral displacement in opposite direction with the same magnitude. That is T1 tan theta 1 will be equal to T2 tan theta 2. Okay. So T1 is 1 centimeter into tan theta 1 is 45 degree, right? So tan theta 1 is 1 equals to T2. T2 it has been asked into sine into tan theta 2 theta 2 that is root 3. So T2 will be 1 upon root 3. So now let's come and solve the question number 15, the last question of this paper. So let's see what it is asking. Two monochromatic sources emit light at wavelength lambda and lambda by 2, and their stopping potential are found to be 1 volt and 3 volt respectively. What is the work function of the material? So it is a equation of modern physics. So let's solve it. Kinetic energy, we know that kinetic energy equals to hc upon lambda minus phi, right? H nu minus phi. So E into stopping potential equals to hc upon lambda minus phi, and so for one of them 1 equals to hc upon lambda minus phi, and for other 3 equals to hc upon lambda, that is lambda by 2 minus phi. Now equate the hc upon lambda. So hc upon lambda is equals to 1 plus phi equals to hc upon lambda here, and here 3 plus phi upon 2 equals to hc upon lambda. So equate these two. So 2 plus 2 phi equals to 3 plus phi. So phi equals to 1 electron volt is the answer. So A option is correct. So hopefully you enjoyed the video, and thank you.